all yours. Thanks.
Thank you, Cassidy. Hi, everyone. Hope you're having a great time here in Summit. In this session, we're going to be talking about Amazon Aurora Zero ETL integration with Amazon Redshift. My name is Surendra Munimohan, a database specialist solutions architect focusing on relational database engines. Along with me, we have Paul Vilena, who's a senior analytics solutions architect focusing on Redshift. He'll be joining in the second half of this session. Oh, is it moving? Sorry.
There you go.
Here's an agenda for today's session. First, we're going to be discussing about what is operational analytics. Next, we discuss about what are the AWS services which helps you to operate, to get more operational analytics for your data. And then we talk about some of the recent developments that we made in the zero ETL space. And then we're going to be talking about zero ETL deep dive and its future. And also Paul has shown you a demo that he has built it for you all here. And then, so the goal of this session is to leave you all with a good understanding of what AWS, what zero ETL future can help you for your team or not for your business, so that you can go ahead and try it out in your account, so that you can see how easy to set up and operate it on scale. So first, let's discuss about what is operational analytics. As the customers become more and more data-driven and they started to use the data for their strategic advantage, there is an increase in need to access the near real-time analytics for your operational data, right? And there are several use cases that can go with an operational data. First one is personalization. For example, if you want to offer your customers the best experience based on their own preferences and needs, you can able to use their operational analytics, right? And the second use case is a fraud detection, or you can do churn prevention. And these are all like horizontal use cases which can be applicable across different industries. And then there is the industry-specific use cases, for example, powering the gaming leaderboard or Internet of Things, so that you want to understand how the devices are operating at the same time, right? So the goal of all these use cases is to get the operational data in near real time, so that you can able to analyze how it is operating, so that you can able to take in insights, and you can able to gain insights from that. So next, I just want to take a quick poll here. Can I please get a show of hands? How many of you are currently building a ETL pipeline for an operational data? Okay, I see quite a few hands here, so I assume like I'm speaking to the right audience. So as you know, building this ETL pipelines often requires like a complex architecture. You need to spend a lot of effort and a lot of time in terms of monitoring it and also managing it. That's why AWS investing in the zero ETL features, where we wanted to make it simpler for our customers to move their operational data from your operational data store to an analytics data store to a Redshift. Next, I just want to talk to you about what are some of the services which is involved in AWS, which is powering this operational analytics, right? First is Amazon Aurora. How many of you are using Amazon Aurora at the moment or planning to use? Okay, I see some hands here which is already using, which is great. So I just want to quickly talk about what is this Amazon Aurora is. Amazon Aurora is a relational database, which is high performance and highly available database, which is compatible with the MySQL and open source database engines. And Amazon Aurora gives enterprise-grade features that you get from a commercial engines with a one-tenth of the cost. For example, like automated backup, automated recovery, and a cross-region replication, and so on. And also the key that we made in Amazon Aurora is a storage layer. Whenever you perform any commits, we write it to a storage layer that's spread across on a 3 availability zone. We have 2 copies of data in each availability zones. So whenever you perform a commits, we send it across to all 6 storage nodes, but we use a quorum-based model for an acknowledgement from the storage nodes. So these storage nodes are not just for high availability, but also for a high throughput, because whenever you perform writes, all we do is just write to the redo log and then push it to the storage nodes. Because of that, we get like higher throughput both for MySQL and also Postgres compatibility engines. And these storage nodes are great for high availability, right? You don't need to do anything. When you create your Aurora cluster, it automatically spread across on 3 availability zones. We automatically set up for high durability. And for the customers who needs durability across the regions, we have Amazon Global Databases, where you can able to set up the Aurora clusters between 2 different regions. For example, if you have Aurora cluster running in a primary Sydney region, and you can set up the DR in a Melbourne region, where we automatically set up the storage-based replication between those regions. And then whenever you want to perform a DR activity, we can just fail over to the different region at any time, right? And on the other side of it, we have Amazon Redshift, which is an analytic data store, which is in a fully managed enterprise-grade petabyte scale data warehouse, where customers can able to analyze the large amount of operational data, either it can be a transactional data or a click stream or IoT, and they can able to push it to a Redshift, where they can able to run an analytics on top of the Redshift data stores. And also, we have launched a lot of new features in the recent years. One is an Amazon Redshift serverless, where it can automatically scales based on your workloads. And then we have added machine learning and Gen AI capabilities, where it can able to work with our SageMaker, where it can able to call the SageMaker, where you can able to run the machine learning. Paul will show you the demo on the Gen AI capability as well. And also, once the data is in the Redshift, where you can able to analyze them and visualize them using on a different tools that we have. Next, I want to talk about on what are the reasons that customers can able to build, customers building this ETL pipeline, right? For example, if you have to move the data from your operational data store, either it can be a Aurora or it can be a it can be a RDS or anywhere, right? If you have to move to operational data store to Redshift, customers has to go on a multiple step journey. For example, they extract the data using their own custom built pipeline, or they use some kind of AWS services, and then they put it to an object store as an intermediate step. And then from there, they kind of use some kind of map reduce, something like that, to you can able to transform it, and then push it to a Redshift store, right? So as you can able to see, there is a lot of operational overhead when you're managing it. It may be okay for some customers who want to transform their load by using these kind of services. But for the customers who wanted to make a simpler solution, just want to move the data from Aurora to Redshift, then they can. That's where the zero-ETL comes into play. This zero-ETL is basically like simple and secure way for a customers to move the data from your Aurora cluster to a Redshift data store without having to manage anything, right? And if you're running on a multiple databases, if you're running on multiple Aurora clusters, you can able to use this zero-ETL to move this data to a single Redshift clusters, because that's what most customers does, where they use like a multiple Aurora clusters and then push it to a single Redshift data store, so that they can able to run and analyze on top of this data store to do that. And also, Paul will show you more on this on the demo as well. Next, I want to talk about what are some of the recent developments that we made in this space of zero-ETL, right? So we announced the zero-ETL last year, and then it was in a preview, and then it recently made to generally available in a few months ago. Since then, we added a number of new things. For example, now it is available in different regions. Now it's available in Sydney region as well. If you're using on a zero-ETL, if you want to try it on zero-ETL, you can go to your Sydney AWS account, and you can able to create that for now. And also now we support an API and CLI, so customers are able to create the zero-ETL using API or command line interface. And also we improved the getting started guide, and also we have we also added the new event notification, so that you can understand what happens as it happens in the zero-ETL integrations. And also, most of the customers were requested for a new data type, which is a JSON data type. Now we added support for JSON data type. And also, just a few days ago, we added a data filtering for customers who want to move only specific tables or only specific data from an Aurora cluster to a Redshift. Now you can able to do that as well. You can able to select only the clusters or tables that you want and move on from there. And for customers who are using Aurora Postgres, now we support zero-ETL integration for Aurora Postgres as well. It is available in a version 15.3 higher. At the moment, it's only available in US West 2 region. So if you want to try it out, you can create it in the US West 2 region, and we'd like to share if you have any feedback, please feel to share it. And one thing I want to mention is, regardless of if you're using Aurora Postgres or MySQL, the way that Aurora integration works is almost a similar way. There is no change in terms of how it works. Now we came to the important piece. Let's talk about a little bit on Aurora zero-ETL, right? So there's basically 3 steps, which is basically simple to set up. So I'll talk to you about each of these steps, how it is simple to set up, and how it is to manage. And once you get to the Redshift, then you can able to take this powerful analytics using the machine learning models that we have. In terms of setting up the zero ETL, all you need to do is an IAM policy. So using this IAM policy, you can able to give permissions to the user who want to set up this IAM policy, you want to set up the zero ETL integrations. And also, if the customers who are running the Aurora in different account and Redshift in different account, you can able to do that as well. You can using the same IAM policy that you can able to integrate that with the 2 accounts so that customers can able to move the data from an Aurora to Redshift. On top of that, we have monitoring and reporting capabilities. So we automatically take an action if something tables fails. We automatically reseed the data. We don't need to do anything. You get a notification on when it happens. And also the resiliency is built in place, given that you don't need to manage on the zero ETL. Next, I just want to show you how we made the zero ETL work in Amazon Aurora. So as you know, in Amazon Aurora, we have a 1 writer instance, and you can have up to 15 reader instances. And this cluster storage is spread across on a 3 availability zone, and we have 2 copies of data in each availability zone. So whenever you perform a writes, you perform a transaction log, and then transaction log get pushed to the storage layer. So it's all the redo logs, right? But in Aurora MySQL, if you have to do capture the change data capture, we use the called binary log. Binary log is the one which captures the changes, and you can able to use those information to push it to the other storage nodes, for example, using for replication and so on. But the issue is that whenever customers enable the binary log, we see up to like 50% of degrade in the performance because you're writing your transaction log and also you're writing to the, this binary log. So we added a new feature called enhanced bin log. Enhanced bin log, which is available in Aurora MySQL 3.03 and higher. How enhanced bin log work when compared to the community is that if you look at the top right-hand side corner, that's a community bin log. So whenever you perform any commits, we write to the, it writes to the transaction log, and then when you issue a commit, and then it writes to the binary log. So which means it writes serially whenever you perform a commit, which means it takes a 2-phase commit protocol, and then it performs a commit. So during that time, there is an increase in the latency, and also it reduces the performance. But if you look at the bottom right-hand side picture, which is enhanced bin log, where whenever you perform any commits, we parallelly write on the transaction log and also on the binary log at the same time, which means we reduce the 2-phase commit, and also we remove all the lockings that are happening in between, so that we can able to use this enhanced bin log to push the data to a Redshift cluster. That's a methodology that we are using here. So using this enhanced bin log, that's one of the prerequisites if you have to use zero ETL with the Redshift. So you just need to have the enhanced bin log turned on. Once you turn it on, then we first seed the data, which is basically take a data, full copy, and then push it to a Redshift. And once the full data is in the Redshift, and then we do the CDC streaming. These are all happening at the storage layer, so there is no you don't need to worry about if your writer instance or reader instance going to be impacting, have any impact on the performance. Because given that we are all using the storage layer to push the data from an Aurora to a Redshift clusters. And then once we start the CDC, and then we monitor it regularly to make sure if there is any changes, or if you need to reseed if any tables are failing, and then we reseed that particular table, and then move on from there. With that, I'm just going to pass on to the Paul, and then he's going to show you a demo on how it works in action.
All right, thank you, Surinder. Hi, everyone. I'm Paul Villena. I'm a Senior Redshift Solutions Architect here at Amazon Web Services. So today I'll walk you through a demo of how we are able to put the zero ETL feature to work and enable operational use cases using the same data warehouse that you have, which is Amazon Redshift. So in this demo, we're going to take on the persona of a logistics company. This logistics company recently went through a modernization program where they broke down their monolith into individual microservices. And so they ended up having many Aurora MySQL databases. So they have an Aurora MySQL database for their logistics fleet application, which sends IoT data from the logistics vehicles going to Aurora MySQL. They have another database that has the consignments information where all of the orders from the customers are coming in. And another database to store their customer interactions, which is really their CRM. Now, the data team of this company, they're more comfortable with SQL, And so they decided to use Amazon Redshift as the cloud data warehouse and the core of their data platform. So they're already using Redshift for their historical reporting, like building BI dashboards on top of it. But with this zero-ETL feature, they can now use the same platform to power operational analytics use cases. So now I'll go into the demo. So here's an example of a Grafana dashboard. It's able to surface some of their key performance indicators like revenue, cost, profit, and other delivery metrics. They can change the granularity of the data or the recency of the data, maybe they're interested in a specific time window. They can also drill down to individual consignments information. And here it surfaces some of the results of a machine learning model who tries to predict what's the likelihood of a consignment getting delayed. And it scores it as low, medium, or high. And all of this data is based on transactions that happened only a few seconds ago. For example, and that really allows them to respond to disruption. For example, they can see here a slightly increasing trend of transactions that are scored with a high likelihood of getting delayed. And that seems to be concentrated in the state of New South Wales, right? And so using that information, they can correlate that with the fleet data, and in the fleet data, they see that some vehicles are going into unscheduled maintenance. So with that, they can maybe decide to rebalance their fleet, move some vehicles from different states, or change their maintenance schedule. So this is just an example of a use case, right? And so this is how we built this. This is the console for Aurora MySQL. Here you'll see that there are 3 different databases, one for customer, the other for fleet, and the other for consignment. And I'll walk you through the process of enabling zero-ETL. First, we need to make sure that enhanced binlog is enabled, as Surinder mentioned earlier. That is a prerequisite. And on the Redshift side, we need to enable case-sensitive identifier. And through a few clicks of a button in the console, we can set up that zero-ETL integration. So I'll click zero-ETL integration. Now I'm going to specify an integration name, like example-customer, and then click next. Now I'm going to select the source database, and I'm going to choose customer DB, and then select the available Redshift data warehouse to me. It can be in the same account or in a separate account. Here I'm going to put it in the logistics data warehouse, and then click next. And I'll leave everything else as default. So that's really how simple it is to set up zero-ETL. And you can automate this, so you can implement this at scale using APIs or command line calls. Now, after we've set up that zero-ETL integration, we'll be able to start accessing that data in Amazon Redshift. So now we're in the query editor interface, and I'm going to create a database to represent each of those zero-ETL integrations. So we'll have one database for the customer, another for fleet, and the other for consignment. So when we do the zero-ETL, there will be a one-off seed where it copies that data from Aurora MySQL to Redshift, and we can start introspecting that on the Redshift query editor. So here in the customer's database, there's already a customer's table, and we can start running queries against it after that zero-ETL is set up. So now I'm here in Aurora MySQL, so I'm logging in using dbeaver, which is an open source tool. I'm going to create a new table called customer reviews, and I'll just verify that that table is created in Aurora MySQL. I'm going to look at the schema, just verify that that table is created. And then I'll go back to Redshift and start running queries against that new table. We'll see that zero-ETL handles both ingestion of data, as well as if there's new tables, the DDLs is also being synced by this feature. So right now there's no data. So what I'll do is go back to Aurora MySQL and insert some records in that new table that we just created. I'll double check that those records are generated. So I'll just view the data in Aurora MySQL. And on Redshift, there will be a few seconds latency. So that's why we call it near real time. And then after a few seconds, that data will exist in Amazon Redshift. So that's really how simple it is. What I'll do next is I'll go to another database. There will be a consignments database in Aurora MySQL. And in this consignments database, I've created a stored procedure. This stored procedure automatically generates new records every few seconds. So it's continuously generating data. And on Redshift side, I see there's 1,000 records at the moment. And after a few seconds, you'll see that the data will change. It's now 1,065 records. Sorry, it's a little bit small, but yeah, the data is changing. And this comes with a built-in monitoring within CloudWatch. So in the console, you'll see there's some CloudWatch logs that you can view, which shows the lag or how long it takes for the data to go from Aurora MySQL to Redshift. There's some high-level metrics like how many tables are being replicated, how many tables have failed. You can even go down to individual tables to see how the synchronization process is working. All right. So now that we're able to unify all of the data coming from different databases, in Redshift you can even unify your operational data with your transactional data, or even access data from your data lake. So there's a lot of power that you can, analytics that you can do on Amazon Redshift. You can even use some of the built-in functions, SQL functions, in order to generate new business metrics that is more meaningful for your business. And all of this you can do in Redshift without impacting your source system anymore. So that's the biggest value. And then you can apply some functions. Here I'm using geospatial functions. I'm calculating the distance from sender to receiver. And you can even integrate other services within AWS, like the location services, to do geocoding if you need to, right? So once it's in Redshift, you can do other things outside of understanding what happened in the past. We have Amazon Redshift ML, which is really allows that integration between Redshift and SageMaker, which is a purpose-built tool for ML and AI. So here I have some historical data, and I'll use that to create an ML model. So using a familiar SQL syntax, I can specify that, okay, these are my training data set, and I want to predict the probability of a consignment getting delayed. I have other parameters here, but it really integrates with Amazon SageMaker. Here you can see the parameters, like some of the metrics of that model. How is it with accuracy? And the output of that will be a prediction function that would allow you to make inferences on new data that's coming in. So this Amazon Redshift ML, we're still heavily investing in this. Now in preview, it's available that you can also integrate with large language models. So for example, with the customer review data that we had earlier, we can do sentiment analysis, and all of that happening within Amazon Redshift. So that's it for a quick demo today. I just wanted to emphasize that in Amazon Redshift, operational databases is just one of the data source. For example, you have streaming data that is residing in Amazon Kinesis data streams or Amazon Managed Kafka service. We can also ingest that using a native feature called streaming ingestion. Or for example, if you want to access public data sets that are available in Amazon Data Exchange, Amazon Redshift also has that built-in integration with that service. So the idea is to really give you the power to unify your data so that you have a full view of your business across different angles, across different systems. And once your data is in Redshift, we provide you with different compute options, right? So you're not really, now we have an option, if you have a steady state workload, then maybe provisioned cluster makes more sense for you. Or if you only want to pay for when a query is running, we also have Amazon Redshift Serverless, right? And you don't really have to copy your data between these different compute engines because of that separation of storage and compute. So Redshift has what we call Redshift Managed Storage. And with that, you can share your data between different compute engines. So you can share it across provisioned or serverless. And so you can have a setup where you have different workloads running on different computes. And Redshift is really there, and the main idea is to make analytics accessible to as many users as possible, to as many use cases as possible, without really having to worry about the underlying technology, right? So it's really everything can be done via SQL, and we're even trying to cater for more personas in the future. So there is a generative SQL feature that's already available in preview in the US regions, and the idea there is you can ask natural language questions, and we will convert that into SQL and give you some results. And so the idea is to really make analytics accessible to more users. And for some reason, like if you don't want Redshift to do the transformation, and you want to interface Redshift with other open source engines, we also have integration with open source tooling like Apache Spark integration. So that's it for today. I really hope that you have a glimpse of what we are seeing as a zero ETL future here in AWS. We know our customers are heavily investing in using our service, and we want to take that heavy lifting away from you, and so you can focus on just generating insights for your business and really be more competitive in this environment. So I really encourage you to learn more about these tools that we have. We have AWS Skill Builder, which is an online learning platform. And we also, there are other training programs available to you as well today. So there's also the training and certification booth outside, so please check them out. And I really encourage you to learn more about these amazing tools. And I'm really excited of what you'll build. So thank you so much for your time today. We really appreciate it. I really appreciate as well if you can give us feedback so that we can learn more about what matters to you as you're building in AWS. Thank you so much.
Thank you so much, Paul. That was really, really good. I'm sure you all learned a lot today. Please be sure to provide some feedback. Please just make sure you rate the session. Do it in the app. It's important for us to know what you think about these sessions. Thank you very much. If anyone's got any questions, please speak to Surrender and Paul. They'll be out at the back. The next session is going to be in this room at 3 o'clock. Thank you.